Hi. So for question 2, part 2, we are told, if I add 3 to a number and square the sum, the result is greater than the square of the original number. State giving a reason if the above statement is always true, sometimes true, or never true. Okay, so we've got a small 2-mark question here at the end of question 2 to finish it off. Okay, so the first thing I'm going to do is I'm going to let n be any real number. Okay, so this number that we're talking about, I have to define it. Okay, so I'm going to let n be any real number. You should be familiar with this mathematical notation. So if n is any real number, we are told if I add 3 to the number, so n plus 3, we're adding 3 to it, and square the sum. Okay, so we're squaring this sum. The result is greater than, so this result is greater than the square of the original number. Okay, so the original number is n, so the square of the original number is n squared. Okay, so this is the statement we're given. So let's expand this left-hand side and let's see where we go with this. Okay, so I can now therefore say that n plus 3 multiplied by n plus 3 is greater than n squared. Okay, so now if I expand this bracket, n times n is n squared, n times 3 is 3n, n times 3 is 3n, 3n plus 3n is 6n, and 3 times 3 is 9, plus 9 is still greater than n squared. So minusing n squared on both sides, we're just left with 6n plus 9 is greater than 0. So if I can minus 9 on both sides of this inequality now, I'm left with 6n is greater than minus 9. Now what I can do is I can divide both sides by 6. So n is greater than minus 9 over 6. Okay, first thing when you see a fraction, you should think simplify. 3 goes into 9 3 times, and 3 goes into 6 2 times. So now I can simply therefore say that n is greater than minus 3 over 2. Okay, so for this statement to hold true, n must be greater than minus 3 over 2. Okay, so I can add that little statement in there. Okay, so for this to be true, we have to satisfy this condition here. So I'm just going to finish off with my closing statement. This statement is only true some of the time when n is greater than minus 3 over 2. Okay, and you can try it out. You can substitute values for n on your calculator, and you will find that this will be the case. Okay, so that's the end of part 2. So if you're having trouble with proofs or anything else in this topic, do have a look at the links below in the description, where they'll forward you on to a few useful videos that will help you along the way. And don't forget to like, comment, and subscribe to the channel. Thank you very much, and I will see you in question 3.